In this video, we're going to be looking at the theorem that says angles subtended by the same chord are equal. Angles subtended by the same chord are equal. And in short, when we resonate in exams and tests and formal activities, we say angles in same segment. Angles in same segment. Perfect. Someone can ask, what is the segment? Okay. So I'll show you what is a segment now. So we have P, we have Q here. You see, these are the 2 points on the circle. And I can join them, these 2 points. And the resulting line is called a chord. So line PQ is a chord. A chord is a line that joins 2 points on a circle. Perfect. So a chord divides the circle into 2 segments, a bigger segment and a smaller segment, unless if that chord is a diameter. A diameter is also a chord. Let's say I have a circle here with a center O here, and then I have a point here and a point there. This will pass through there. You see a diameter, this is segment 1, that is segment 2. So a diameter divides the circle into equal segments. But I can draw a random circle here and then a chord which is, let's say, the center is there. So this chord is not a diameter, we can see, but it still divides into 2 segments. Perfect. That is what a segment is. It's just the 2 parts that results when a line divides the circle. Perfect. So now we agree that here we have this segment and we have these angles. Angle A on the bigger segment, right? We have angle B on the bigger segment. We have angle C on the bigger segment, right? So use the V's on top on the angles there. Always, I call this a V method. We're going to use the V method. So any angle you see on the circumference, you put a V on it. Now we're going to do a little research as to where does this angle originate from, right? Remember, an angle must be formed by 2 lines. So for example, angle A is formed by this line, which comes from P, this side, and then it's also formed by that line, which comes from Q, okay? So we say angle A is subtended by PQ. So subtend is like to form, basically. Angle A is formed by PQ, or angle A is formed by PQ. All right. Now let's do another research. Where does B come from? B come from P, this side. Remember, angle is formed by 2 lines. So this line comes from P, and that line comes from Q, okay? So we say also angle B is subtended by PQ. And I'm sure you can see that C is also subtended by P and Q. So we can make a conclusion here to say the value of A is equals to the value of B, which is equals to the value of C. Your reason will be angles in same segment. Same seg. Some people say this, angles subs same chord. Same chord. And then you can name the name of the chord. Same chord PQ. Which I like this one more because it shows that you understand the substand part of this theorem. So I most of the time use the second one than the first one. Right, sure. So that is angles in the same segment theorem, ladies and gentlemen. But someone can ask, PQ also subtends D and E on the smaller segment. So PQ subtends D, because if you check D, D is formed by this line, which is from P, and it's also formed by this line, which is from Q. Similarly with E, E is formed by this line, which is from Q, and it's also formed by that line, which is from P. So we can conclude that D and E are equal as well. And then you're going to say angles subtended by the same chord PQ. Right. And then another question that may arise is this. Are the angles ABC the same as D and E? The answer is no. It's only going to be the same because they're on opposite segments, right? They're only going to be the same only and only if the chord that we are talking about is the diameter. So this angle will be the same as that one there, right? But otherwise, they cannot be the same, right? But there's a special relationship between these angles. Ne? The angles subtended by the same chord in opposite segments add up to 180. We're going to talk about this theorem later. Ne? So we can conclude that A plus D equals to 180. Or you can say B plus D equals to 180. 180 degrees. Or you can say B plus C equals to 180. Because these two angles are subtended by the same chord. This is in segment 1. That one is in segment 2. When you add them, they must be adding up to 180 degrees, as long as they are subtended by the same chord and they are in the opposite segments. All right. The theorem is called opposite angles of a circle, ne? Of a cyclic chord, I mean. Opposite angles of a cyclic chord. We're going to talk about it later in the playlist, okay? But for now, I'm sure you understood what is angles in the same sec and how to use it. Thank you very much. The next video will be doing activities on angles in the same segment. Please tune in. Aluta continua. Tango.